Okay, it's something that you might need to do first. If the top of your notes says Unit 1, Day 4 notes, scratch that out and put Day 3. We're actually on Day 3 now. Solving absolute value inequalities. I'll let you read through that on your own, but something that I really want to point out is this area right here. If your absolute value is isolated and you're left with a less than or equal to, or just a less than, that is a and statement. And I'll definitely describe what that means in detail a little bit further. Look here now. When the absolute value is isolated, if it's a greater or greater than or equal to, that is a or statement. And when we come across one of those, I'll show you what that's going to look like. Okay, this right here. Notice the absolute value is isolated. Great. Now, take a look at the inequality. This is a less than. Think less than. This is a less than. So I want to make a note to myself. I'm going to write that this is an and statement. And what we're going to do is, since the absolute value is isolated, you're going to create two problems like we learned last class. But look what's different about this. Since it's an inequality, flip the inequality and make the 3 negative, and then solve both of them. So we get x is less than -1 on the first one. And x is greater than -4 on the second one. Now I'm going to remove this piece of paper because I don't have much room. Once you have your inequalities solved, you're going to want to graph them on a number line. And you want to graph them from least to greatest. You know, think on a number line. This is where, let's just say, -10 is. And if we were to continue going this direction, we have -10, -9, -8, -7, all the way over. We're gradually getting bigger, right? Well, the only numbers that I care about, that you put on your number lines are the ones that we absolutely have to know about. And once again, make sure you put them in order from least to greatest. So let's put -4 here. And let's put -1 there. Now, this might help you if you don't know what to do from here. Above these numbers, I'm going to write the inequalities when we solve them. Remember, x was greater than -4. And here, x was less than -1. Now, since both of these are not equal to statements, you want to put an open circle above both of those numbers because they don't have that little line underneath the inequality. Next, if you don't know where you need to start shading, this might help you. Look at this inequality. If you were to draw that little tail, doesn't it look like an arrow going that way? So we want to shade a little bit this way. And over here, the arrow's going that way now. So we want to shade a little bit this way. Now listen, this is what and statements usually look like. Not always, but usually. It's normally two dots on a number line that are connected. They don't go past one another. All right. Now we have to put our solution in set and interval notation. Now, interval notation is going to be the one that we're mainly going to use. That's the most important one. So that's the one I'm going to start with. And I like interval notation because it's much easier. Notice that our solution lies somewhere in between -4 and -1. But since these are open circles, that means it doesn't include -4 or -1. So we know it's in between -4 and 1, and just use parentheses. If you have open circles, your numbers need to have parentheses. Now, as far as set notation goes, and statements are a little crazy. I'm going to draw that out and then I'm going to explain it. Now that I have that written, I'm going to tell you what this represents. All solutions of x such that -4 is less than x and x is less than -1. Now, in my opinion, the most important part is that you get the -4 is less than x and x is less than -1 part right. And it's not too difficult to remember as long as you know, well, you have to go from least -4 less than, put an x, less than, end with the greatest number, -1. These inequalities, if it's an and statement, will always be pointed that direction. They'll always be less thans or equal to, I suppose, if it was an equal to statement, but they weren't. Let's take a look at example 2. The absolute value of 10 minus x is greater than 4. The absolute value is isolated. Notice this is a great or sign, great or. So this is an or statement. This is a or statement. Now, since the absolute value is isolated, we're going to go ahead and set up our 2 problems. There's the first one. Flip the inequality, change that +4 to -4, and then start solving them both. All right, now watch this. I'm about to have to divide by -1. When you divide an inequality by a negative, the inequality flips. X is less than 6. X is greater than 14. Now let's go ahead and put this on our number line. Remember, least to greatest, 6, 14. And right above the 6, if you need help with this part, x is less than 6. That's the inequality we solved there. And here, x is greater than 14. Since neither one of these are an equal to statement, this one wasn't an equal to statement, so give it an open circle. This also was not an equal to statement, so give it an open circle. If we were to draw a tail on this arrow, it'd be going that direction. So draw an arrow going this way on your number line. It's going to keep going that direction forever. Here, if we were to draw a tail on that arrow, it'd be going this direction. This is going to be going to the right forever. So let me point something out. This is what ORs usually look like. Not all the time, but usually most of the time, at least in this class. So if it's an OR statement, usually 2 dots going opposite directions. If it's an AND statement, it's usually 2 dots that are connected and will not go past one another. Let's do interval notation first. As I mentioned here, this arrow is going to continue going to the left forever. That direction is -infinity. This arrow is going to go to the right forever. That direction is +infinity. So when we go to build our interval notation, let's do it from left to right. So we're coming from the left. So that's -infinity, comma, we are approaching 6. And since it's an open circle, give it a parenthesis. Then draw this union. It pretty much means or. Or we're picking back up at 14 and we're going all the way to +infinity from there. That's a comma right there. Looks like I accidentally put a period. and then the parenthesis gets, I'm sorry, the infinity gets a parenthesis. By the way, infinities will always get parentheses and interval notation. And now let's do our set notation. If it's an or statement, it's a little bit easier. Remember when we solved, we got x is less than 6 or x is greater than 14? Sorry about the arrows. Now it kind of looks a little messy. That's pretty much our set notation. X is less than 6 or x is greater than 14. That's what I'm mainly worried about, okay? But don't forget that we're really supposed to have this stuff too. Then close it with these fancy looking brackets. I'm mainly worried about this though. X is less than 6 or x is greater than 14. All right, example 3. The absolute value here is not isolated. So start by subtracting 7 from both sides of the inequality. Two minus 7, negative 5. Now that the absolute value is isolated, oh wait, yeah, oh, okay, sorry, I'm kind of getting ahead of myself. Now that the absolute value is isolated, look at the inequality. This is a less than or equal to. So less than, and less than. This is an and statement. Do you remember what and statements should look like most of the time? Two dots that are connected. Almost every time, not all the time. Let's create our two problems now that it's isolated. There's the first one. There's the second one. Remember, flip the inequality, change the sign. Let's solve. Okay, I'm going to go ahead and just use this piece of paper for my number line here. Let's go from least to greatest. -8 there, +2 there. These are both equal to statements. So bubble them in. No open circles. Bubble them in. All the values where x is less than or equal to -8 are this direction. All the values where x is greater than or equal to that direction. Do you remember what and statements usually look like? They usually are two dots that are connected. This is what and statements will never look like. They can't be two dots going in opposite directions. This is a no solution. But now I'm going to point something out here. You might have noticed something a little funny to begin with. Remember when we isolated our problem here? Look at this number. Now you need to ask yourself, will an absolute value ever produce a number that is less than a negative? No, don't be ridiculous. Remember, absolute values produce positive results. So we could have stopped right here, to be honest. An absolute value will never produce a number that is less than a negative. All righty then, example 4. The absolute value is not isolated. You're going to have to start this problem by dividing by 3. Now that the absolute value is isolated, create your two problems. There's the first one. Flip the inequality, change the sign. Let's solve. Oops. Okay, let me rewind a little bit. Something I forgot to point out again, and my apologies for doing this. This is where we isolated the inequality. What's the inequality once it's isolated? It's a less than. This is an and statement. Do you remember what and statements usually look like? Two dots on a number line that are connected. Let's see how this one turns out. All right, here's my number line. Let's start with -10 first, +8. Let's see. Both of these are not an equal to statement, so both of our numbers get open circles. Now, all the values where x is less than 8 are this way. And all the values where x is greater than -10 this way. So that's what we should expect more times than not, a and statement to look like when we graph it on a number line. All right, and now we're going to do our interval and set notation. Let's start with set notation first. So let's start with the -10. Then your inequality, which is always going to point that way if it's an and statement. And then x. And then your inequality if it's an and statement. And then the bigger number. So least to greatest. And then now we got to put all this stuff in here. Boom. That's your set notation. Now let's do interval, which is way easier. Our solutions are in between here from -10 to +8. -10, +8. Since these are open circles, since they're not equal to, give these parentheses. So now you have your set. Now you have your interval. Okay, look at example 5. Is the absolute value isolated? Yes, it is. Is the inequality an and or an or? Well, it's a less than, so it's an and statement. And it says it's less than a -10. Do we even have to continue with this problem? No, we don't. Because remember, an absolute value will never produce a number that is less than a negative. So you can go ahead and just write no solution here, pal. You didn't think I was going to do that, did you? If you know me, you probably knew I was going to. All right, take a look at example 6. This one here, the absolute value is not isolated. So the first thing that you're going to want to do is divide both sides by -2. Since we're dividing by a negative, flip the inequality. All right. Before you start jumping with joy because, hey, we don't have to do this one because there's a negative. Hold your horses. The absolute value is isolated. Is this an and or an or statement? This is a great or sign. Okay, now do you remember what ors usually look like? Two dots in a number line going opposite directions, usually. Not all the time, but usually. Now, let me show you the difference between an and an or when we're dealing with a negative. Will an absolute value produce a number that is greater than a negative? Oh, yes, it will. Every single time. So we have to solve this one. Since it's isolated, create your two problems. There's the first one. Flip the inequality, change the sign. Start solving. That's what I got for the first one. Let's solve the next one. And that's what I got for the second one. Let me create some room here. Okay, I'm going to draw my number line. Let's write our numbers down from least to greatest. Now, both of these happen to be an equal to statement. And let's figure out what our arrows are going to look like. Now, usually they look like this, right? For an or statement, that's what they usually look like. But let's see what this one does. X is greater than or equal to -3. Where all the values where x is greater than or equal to -3 are this direction. Here, x is less than or equal to 1/3. Where all the values where x is less than 1/3 are this way. So these two solutions, they're both going at one another. Now, if it was an and statement, everybody, we would stop. We would stop here. This is where our solution would be. But if it's an or statement, this is going to keep going this way forever. It's going to keep going that way forever. It's not going to stop. It's going to cover every single number on the number line. And if this arrow is going this direction forever, well, this direction is negative infinity. And if this arrow is going that direction forever, well, then it's positive infinity. So everybody, our solution in set notation is all real numbers. And in interval notation, if your solution is all real numbers, then you're going to do this. Negative infinity, comma, positive infinity. And remember, infinities get parentheses. So here we have our set, and here you have your interval. Example 7. Identical vacation cottages equally spaced along a street are numbered consecutively, beginning with 10. Maria lives in cottage 17. Joshua lives 4 cottages away from Maria. What are the possible numbers of Joshua's cottage? If n represents Joshua's cottage number, what absolute value equation will produce the correct answer? So even if you didn't quite know where to start, you could at least draw some sort of diagram. Okay, this is house 17. Josh could live 4 houses this way and be in house 21, or he could live in 4 houses this direction and be in house 13. But in order to figure out what the equation would look like, the absolute value equation, here's what you're going to do. Absolute value in to represent the number. Well, let's pretend we don't know. It's either 13 or 21. Minus, what was her number? 17. Close absolute value. And we're going to set that equal to Joshua lives 4 cottages away. We're going to set this equal to 4. Now, it just wanted the equation. That's all it wanted. So this right here is your answer. But by now, you know how to solve this. You would do n minus 17 equals 4, and n minus 17 equals -4. And if you solve both of those correctly, you'd get 13 and 21. All right, let's take a look at example number 8. Martin makes exercise weights. For his 10-pound dumbbells, he guarantees that the actual weight of his dumbbells is within 0.1 pounds of 10 pounds. Write and solve an equation that describes the minimum and maximum weight of his 10-pound dumbbells. Let X stand for the actual weight of the dumbbells. So we're going to let X stand for the actual weight. Now for the 10-pound dumbbells, let's do minus 10. Close your absolute value, less than or equal to, and then the margin there, 0.1. They're going to be somewhere in that range. This is an and statement. Let's make a note of that. Remember what and statements usually look like? The absolute value is isolated. So let's solve. There's the first one. Negative 0.1. There's the second. Let's solve them. X is less than or equal to 10.1. X is greater than or equal to 9.9. Negative 0.1 plus 10, 9.9. If you wanted to graph these on a number line, you could. Start from least to greatest. Both of them are equal to. So equal to, they're going to get bubbled here. All the values where X is greater than 9.9 this way. All the values where X is less than 10.1 this way. And this is what ands usually look like, two dots that are connecting. Now I want to show you how you would write this in interval notation. I'm going to accept interval notation as an acceptable answer here. Now we know it's going to be from 9.9, comma, to 10.1. But since these are closed bubbles, since it's an equal to statement, you now get brackets. Notice the difference between equal to statements and not equal to statements if you're writing interval notation. Last word problem, example 9. Jonas is shopping for a new tablet. He's found one for $225, but the salesman at the electronics store has told him the price of the tablets could differ by as much as $75 from the one he was looking at. Write and solve an absolute value inequality to find the range for the costs of the tablets according to the salesman. Does this sound reasonable? All right, so let's get going. Absolute value, X minus, he found one for $225. Close absolute value, less than or equal to. Now, it could differ by as much as $75. So we want to put that over here. This is an and statement. The absolute value is isolated, so create your two problems. There's the first. There's the second, and now we solve. Let's solve this one now. And let's put them on a number line. 150 first, 300 second, equal to statements. So let's bubble these in. All the values where X is less than 300. This direction. All the values where X is greater than 150. This direction. So if you wanted to answer this in set notation, you could do lower number, inequality, X, inequality, bigger number. Don't forget though, they were bubbled in, so they're equal to statements here. And then if you wanted to write your answer in interval notation, it's going to be in between 150 and 300. Since they're bubbled in, bubbles get brackets. So it's going to range anywhere from $150 to $300. Good job, everybody.